Page 335, number 55, asks us to solve the right triangle, which means to find the values of all the unknown parts. And we were given a picture, triangle ABC, and we were given the value of one angle and one side. Now this is very normal for labeling a triangle when it's labeled ABC. Usually the two acute angles then are labeled alpha and beta, the corresponding Greek letters. So we're given angle alpha, we're given side A, which is the side opposite angle alpha, and we can go ahead and find all the other parts. Now the first one I like to find is beta. It's the easiest one because we know that the angles of a triangle have to add up to 180, and one of the angles is 90 degrees, so alpha and beta have to add up to 90 degrees. So beta is going to equal, let me write that a little nicer. Beta is going to equal 90 minus 20 degrees. So beta is going to be 70 degrees. Now what we can do is use the fact that we have two of the three parts of finding sine of alpha. We know that sine of alpha is going to equal the opposite side, which is A divided by the hypotenuse. So we have sine of 20 degrees is equal to A, which is our 12.3, divided by side C, which is the hypotenuse. So we can solve this for C. So C is going to equal 12.3 divided by sine of 20 degrees. And you want to make sure, since the last time I used my calculator I was using radians, that I switch my mode back to degrees, and I get that side C equals 35.96. Now you could have also, if you wanted to, found tangent first, which I'll show. From here, since we have A and C, we can use the Pythagorean theorem to find side B. You can also find side B by using tangent of alpha. So we could have just as easily started by taking tangent of 20 degrees is going to be the opposite side, which is A, which is 12.3, and divided that by side B, which is the adjacent side. And again, we would have been solving 12.3 divided by tangent of 20 degrees. And we would have gotten the same answer. Actually, no, we wouldn't get the same answer because we were solving for B this time, not C. So we get B is 33.79. And again, if you would have found that first, then you could have used A and B to find C by using the Pythagorean theorem. Now, one thing you want to be careful of when you're doing this is to make sure that side C, which is your hypotenuse, is indeed the longest side. So you have your ratios correct. So now we are finished because we have all our values. We know that alpha equals 20 degrees. We know that beta is 70 degrees. We have side A is 12.3, and we're not given any units. B is 33.79, and side C is 35.96. And of course, angle C is 90 degrees.